So in this problem, we have a child who's spinning a ball attached to a string on their head. So here's the child, let's say, and they have a string, and the ball is here. And this string is 40 centimeters long. And it's being spun at an angle of 30 degrees to the vertical. So that means here's the vertical. This is 30 degrees. And so if I think about this, this ball is going around in a circle here. And so this is the radius of the circle. And so if I think about that triangle here, this is 30, this is x, which we'll call r actually, and this is 40, then I know that r, or 40, is equal to the sine of 30. And so r will be equal to 40 sine of 30, which I know is 20 centimeters. And let's put it in the terms of meters, so 0.2 meters. And I say that because I'm thinking ahead here, velocities often in meters per second. So there's our r. So now when we get to b part, it says we know that the center of the circle is at the origin of the coordinate system, position of the ball at time t equals 0 on the positive x-axis. So what that means is going on here is now if we look from a bird's eye view, the ball is going around the circle here. Here's the kid's head, and there's his feet kind of thing, and his arms. So we're looking from the down. The ball is going around here. It takes 1 second to go all the way around the circle. So if it takes 1 second to go all the way around the circle, the period is equal to 1. And I also know that if I'm going to graph these, that means the period is 1, the b value of my sine bt or my cosine bt is always equal to 2 pi over the period, which in this case is going to be 2 pi. So now if I want to find my displacement vector, what I know is that my xy then is going to be my radius is 0.2 cosine. The reason why it's cosine is because I know, imagine this goes around here, right? At this point here, this is my x value, which is cosine, and this is my y value, which is sine. So my x value is 0.2 cosine 2 pi t, and my y value was 0.2 sine 2 pi t. And so there is my displacement vector in meters for this vector. So now I want to find the velocity vector. Well, now to do that, I'm going to find the derivative of these values is the velocity at t. Well, I'm taking the derivative of cosine is negative sine 2 pi t times 2 pi from the chain rule. And the derivative of sine is cosine, I know, 2 pi t again times 2 pi because of the chain rule. And if I tidy that up a little bit, I know it's equal to negative 0.4 pi sine 2 pi t and a 0.4 pi cosine 2 pi t. And so this is the velocity vector here. Okay, then moving on. So there's C part, the velocity vector. So now the child releases the string. Find the initial speed of the ball as it's released, given that is the same as its speed just before release. So basically we want to know what happens if we want to find the speed. That means the speed means we are going to find the magnitude of the velocity vector. So when I find the magnitude of this vector here, negative 0.4 pi sine of 2 pi t and 0.4 pi of cosine 2 pi t, when I find that magnitude, one of the things I can do I'm going to go square root of 0.4 pi squared. I'm going to do it, this is sine squared 2 pi t plus, and I ignored the negative because it's squared, 0.4 pi squared cosine squared 2 pi t. If I pull this out as a factor and all the way out to the front, it goes 0.4 pi outside of the square root, and then I get sine squared 2 pi t plus cosine squared 2 pi t. This you should recognize as 1. So my speed is 0.4 pi meters per second. And there is how we can do this problem here. Hopefully that helps.